Welcome students of standard 10. Okay, from this lecture I am starting with science 1. First chapter, gravitation. Okay, see what is gravitation? I think the term is familiar to you. Whatever you throw falls towards the earth. Even you are attracted towards the earth. Try to jump. Again you will fall back to earth. Getting? This is gravitation. Whatever you throw, if I throw something, it will fall to earth. Not, it won't fly here and there. Getting? Without, if a force is applied, it may go here and there. But finally, it will fall to ground. Why it falls to ground? All the objects on the earth are attracted from the center of the earth. This is force of gravitation. Understanding? You feel your weight. That is gravitation. Weight is nothing but gravitational force acting on you. Understanding? Very easy to understand this gravitation. Okay, Earth. You see heavenly bodies, Earth, Moon, Mars, Venus, Sun, Andromeda, whatever. Okay, you see, Moon is revolving around the Earth. Earth is revolving around the Sun. Which force? The force is gravitation. Universal force this is. Gravitation force. Real force. Okay. Who discovered this gravitational force? Sir Isaac Newton. Getting his life from 1642 to 1727. In that he wrote the book Principia. Apple story everyone knows. If ordinary person sleeps and apple falls on him, he will just eat and sleep again. But Newton didn't do that. Oh, it fell on the ground. He threw it again and again. Why didn't it go there? Why down only? And from this thought, he wrote the whole theory of gravitation. Getting it? Because of Newton, we are successful in launching satellites. You know, satellites all over the world of different countries. Getting? That is gift by Isaac Newton, the great scientist. What is the circular motion? In a circle is called circular motion. Moon revolves around the earth. Earth revolves around the sun. Circular motion. Different. You also must be playing with circular motion. Take a string, tie a bob, revolve. In circular motion. If the string breaks, where the bob goes, if the string breaks here, at the tangential direction, you remember UCM, uniform circular motion, you have studied in 9th standard. The object goes the direction of velocity on the circumference is tangential, that is perpendicular to the corresponding radius. If it breaks here, perpendicular, tangential direction. But which force is necessary to produce circular motion? That is centripetal force. You revolve a bob, tying a string around your finger. The force, where is the force? Force given by your finger. That is centripetal force. The direction towards the center, which is necessary to produce circular motion. Getting it? and this is a real force. We'll study, discuss more. Okay, the term you understand. Centripetal force towards the center. The force necessary to produce circular motion. The force is given from center. Understood? The basic things of gravitation? Okay. If you have doubt, you ask me, write in the comment box. Any term, science chapter, you have to read it. Again and again you have to read the chapter. Okay, every time you get new insight. New doubts are produced. But don't worry, I am there to help you. Getting? So different laws on gravitation now we are going to study. Okay? First, Kepler's law. Okay. Before going to Kepler's laws, I want to tell you what is ellipse. Circle you have understood. Circle has just one center and one fixed radius. Okay? But the ellipse, these are not centers, they are two focus. Plural form foci. Two foci of ellipse, F1 and F2. The property of ellipse, any point on the ellipse, getting? Any point on the ellipse has sum of focal distance is constant. Like suppose take point A. AF1 plus AF2 is same, constant. BF1 plus BF2 is same. CF1 plus CF2 is same. Right? Sum of focal distance is constant. This is locus, ellipse. Understood the difference? AF1 plus AF2. This is sum of focal distances. A from F1 focus and F2 focus. AF1, AF2. That is same for any point on the ellipse. BF1 plus BF2, same distance. Suppose this is 10, this is also 10. C, any other point, take here, 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 whatever. CF1 plus CF2, same. This is property of ellipse. Understood? So I'll start with Kepler's law. Okay. See, planets are revolving around the sun in our solar system. Okay. See, but actually they are revolving in elliptical orbit. Understanding? According to Kepler's first law. This is not exact circle but ellipse. The orbit of planet is an ellipse with sun at one of the focus. Getting? The sun at one of the focus. See, this is ellipse. Just now I showed you. This is sun at focus. Understanding? For all, even moon is revolving right that way. All motions are little elliptical and not exactly circular. Okay. Kepler's second law. The line joining the planet and the sun sweeps equal area in equal interval of time. Okay, for planet let us consider 100 days. Suppose one planet is here. In 100 days, it covers this distance. Okay? What is the area? Whatever. Suppose area is whatever big units. So in 100 days here, the length is more but area with sun is less. Getting? But here length is more but the area swept, this area and this area, the distance is less, but the area of this region and this region, 100 days, planet moving here to here in 100 days. But this area, and this is also 100 days, but this distance is more. Understanding? So this also 100 days, but distance is less. But the area of both regions is same. Understood? This is Kepler's second law. So when we are close to Sun, the Earth moves faster because it has to sweep more equal area in equal interval of time. When Earth is far from the Sun, it moves slower. Baki geographical term apogi perigi, I am not mentioning anything about latitude, longitude, whatever. See, this is scientific point of view. Kepler's second law. The line joining the planet and the Sun sweeps equal area in equal interval of time. Understood? Okay. It means I will shade the region. This area of shaded region is equal to area of shaded region. 100 days, suppose for example, or 50 days. If Earth covers this much, 50 days, because it is very close to Sun, but here it will cover this much less distance in 50 days. But the area swept will be same. This area equal to this area. This is Kepler's second law. In exam you have to write word to word. Correct answer. Kepler's first law, Kepler's second law, Kepler's third law, or write all the three laws of Kepler's. Kepler's third law, the square of the period of revolution. The period, the time taken to complete one revolution is called period. The square of the period is directly proportional to cube of the, now every time distance is different. So what we do is we calculate average distance that we call mean radius. So time, the period, square of the period is proportional to the cube of the mean radius. For every planet, okay, the square of the period of revolution around the Sun is directly proportional to the cube of mean distance of a planet from the Sun. So symbol for period is capital T. The square of T directly proportional to cube of mean radius. Formula for sums, numericals, you must know all the formula. T square upon R cube is constant. You have to, for with third law, you have to write mathematical expression also. Getting? Understood the Kepler's law? Any doubt you can ask me, write in the comment box. Comment box is there. And you know how to run finger swiftly. Getting? Your doubts will be cleared. Next lecture. Understood Kepler's law? We'll go ahead with the Newton's law. Okay. See, actually Kepler was much before Newton. Whatever laws written by him were proved by Newton. Newton's universal law of gravitation. Newton wrote the universal law of gravitation. According to Newton, any two objects, every object attracts every other object with a force. Getting? Any force you can calculate like that. But that force is proportional to product of the masses and inversely proportional to square of distance between them. We don't feel the force. Okay? Suppose this board is attracting me. Because our product of masses is very low. Distance upon inversely proportional to square of distance between us. And the value of G is very less. So the force is just negligible. But with Earth, what happens? Earth's mass is huge. 6 into 10 raised to 24 kg. Huge mass. So we feel the force of gravitation by the Earth. Understanding? As this is a law, you need to learn word to word by heart. Every object in the universe attracts every other object with a definite force. This force is directly proportional to the product of masses of two objects and inversely proportional to the square of distance between them. Suppose this is object M1 has mass M1, second object has mass M2. They are attracting each other with anything. Getting? Only the force is visible in case of heavenly bodies like Earth and Moon, and Earth and you also. Force is clearly visible. Any object, because Earth's mass is huge. So F, this is the d distance between the two objects. So force proportional to M1, M2, directly proportional to product of masses, and inversely proportional to square of distance between them. As distance increases, force decreases. Distance increases 2 times, force decreases 4 times. Distance increases 5 times, the force decreases 25 times. Getting it? So this proportionality constant, if we remove, that constant force is equal to G, capital G M1 M2 upon d square. This capital G is universal gravitation constant. The value calculated, that is very less. G is 6.673 into 10 raised to minus 11. And its SI unit is Newton meter square per kg square. You have to learn this by heart. SI unit also may come for fill in the blank. Okay? That's why we don't feel small forces. Because they were very low compared to us. Getting it? Moon is attracting us, but Earth's force is very big. So we are bound to Earth and not fly to Moon. Understanding? This way. So G you can define, it is a force between two objects of having masses 1 kg and distance between them is 1 meter. Understood? What is G? We can define by making this quantities unit. Understood? Definitions you learn from textbook in words, proper word to word. Understood Newton's law? We will see now how he proved Kepler's law. Okay? See, here, the inverse square law I am explaining you. The Newton, we have a G M1 M2 upon d square. Why square of distance between the two objects? See, if a body of mass m moving in a circle of radius r with velocity v, the centripetal force is given by this formula. F is mv square upon r. Okay? So velocity is circular, circumference upon time period, right? So velocity is for circular motion 2 pi r upon capital T. Understanding? Circumference upon time period. Period is, time taken to complete one oscillation, revolution. So for V I am putting this value 2 pi r upon T. So m, 2 square is 4, 4 m pi square r, 4 pi square r square upon T square, but 1 r is cutting. So 4 m pi square r upon T square. At this position, we will multiply numerator and denominator by r square. r square into r is r cube. R square 1 will take here. Okay. So 4n pi square upon r square into r cube upon t square. Actually we know t square upon r cube is constant according to Keplers. So for this we will put k here. M is constant, mass, pi is constant, 4m pi square upon k, everything is constant. Force is inversely proportional to square of distance. Understanding? This explains inverse square law. Understanding? Centripetal force. Any doubt? You write in the comment box. You can ask me. Okay? So in my next lecture we'll go ahead. Chapter is huge. Plus you need numerical practice. Okay? Slowly we will complete the chapter. Okay? If you like, share, subscribe, give like to get and press the bell icon to get new notifications. Okay? Slowly I am covering the total portion. So be with me. Okay? Doubt you can ask anytime. Plus, if you want to join online tuition, my phone number is provided. Okay? You can give call on a special tuition on 1-to-1 if you want. You know, you give call. Email also provided. We'll talk. Okay? See you next video.